Hello all, and welcome to this video about how to create database diagrams in Astah. I'm making this video because I see in the semester project reports all kinds of weird diagrams, and my students often don't even know what the diagrams are telling, and they don't know how to use them, and they're using various diagram languages, whatever you want to call it. And you should be taught in Astah, as far as I know, and that's also what we want to see in the report, so that you don't come up with some strange diagram language and you have to explain what it actually means. So it's just easier if everyone uses the same language, and that would be UML. Now, the reason for most of my students choosing something else is because they don't actually know how to do this in Astah. So this video is going to show you how to create your database diagram. Now, a word of warning: I'm not a database expert, so I may be doing something logically wrong with my diagram, but the tools should still be clear so that you can do it. Right. I have two versions here. This the one to the left here is supposed to be an EER diagram, and the one to the right is supposed to be a physical diagram. And depending on who's your teacher, my impression is that you don't always, in DBS1, you don't always get to this diagram, which I find unfortunate, because this is the diagram that I prefer. It is the one that actually tells the reader how the database is implemented. There are no ambiguities here. Unlike the EER diagram, you can have you can have something in your model that can be implemented in different ways, and so it can create confusion. If I just look at your EER diagram, I may get an impression of how you intend your database to be structured or behave, but it's not clear to me how it's actually implemented. The physical diagram will tell me that. One example is if I have a one-to-many relationship, like this one. So a course belongs to one teacher or is managed by one teacher, and a teacher can manage multiple courses, right? So one teacher can have many courses and one course can have one teacher. I could implement this in two ways. I can either say the course has a foreign key to the teacher's person ID, so each course knows which teacher it belongs to, or I can create this ternary relationship where I create a new table where each entry is a teacher course pair. So for every course owned by a teacher, there is a teacher course pair up here. So a foreign key to teacher and a foreign key to course, the IDs of both. Right. So I have two ways of implementing a one-to-many relationship, and the EE diagram does not show me how the database is implemented. The physical diagram will do that instead, because I have marked all my keys, my primary keys, my foreign keys, my partial primary keys. If I have a composite primary key, this was supposed to be in K, foreign key, not foreign C, whatever. So the physical diagram tells me exactly how the database is implemented, and I find that a lot easier to understand then. But if you're not taught this one, you can really do it. So I think that depends on your teacher. In either case, I'll try to do both diagrams so we can see which tools to use to create, for example, the ternary relationship, or mark the foreign keys, or whatever. Right. So we're going to do that in Astah, and I think we're going to start with this one here first. And if you saw my video about domain models, then it will be very much copy-paste. It's the same tools we're going to use, but we'll just go through it anyway, in case you didn't watch that one. So let's skip to Astah. And there we go. Okay, I have a completely new project. I will just, let me just find the diagram again so we can see that. I'll put that in the background. Okay, I am almost ready. Wonderful. I want to create, so here's the first step that goes wrong for most of the students. There is something called an ER diagram. We're not going to use this one. I don't know what this creates. It creates weird stuff. and it gives me these arrows here, so I can create an entity 0 and 1, and I can create an arrow between them. But this is not UML, I don't really know what the arrow means, so you'll have to explain it to me. And sometimes I see all the attributes down here, but I think everything above the line is actually the primary key. So if you have multiple attributes above, then it's a composite key. And apparently it also creates a foreign key automatically. So, and we have a strong entity, I think, because of the square, and a weak entity because of the rounded edges, but I probably shouldn't tell you too much about this because this is not what we want to do. And the point is just that many students use this one without really knowing how to use the actual diagram language, what the arrows mean, lines, and how to indicate the keys and such. So we will instead go and create I don't want to save, no, I want a new one. Right, I just want I want a class diagram. I create a new class diagram. So that means that it will initially look like a class diagram, and we just have to hide some of the details to make it not a class diagram but an ER diagram instead. So we'll do this one here. I will create a teacher. I will create a person and a student. And there's also a course. Right, so I'll create these afterwards. So for the teacher, I only want to put attributes here. There are no operations. These ones, I don't want these. So we'll just do the attribute. I have a person ID, and it's a varchar. I think in some databases, at least, it's a varchar text string, whatever you call it. I don't know. I can press enter to create a new one. This is a phone number, and I call this number. Yes, and maybe it's called int or something else in your database program. I just call a number here. I have an office. This is also supposed to be a varchar because my office currently is A301B, I think. So I need to mix numbers and letters. I mean, we can put constraints on these, and I'm actually not entirely sure how to show these. Constraint name. Yeah, okay, so I can just say 5, right? My office consists of A301B, so that's 5 characters, right? So I can put a constraint here. Okay, let's move on to the person. So the point here of the person is actually that both the student and a teacher is a person. I could have, they sort of have the same things, so I could probably have collapsed these into one table perhaps, and then just have a boolean for whether it's a teacher or student, or I just found it easier to take whatever is shared between the two, meaning name, password, and email. I put that in a person, and then I sort of create what we might consider inheritance. I think actually Postgres can manage inheritance just like in Java. But the point is that a student just has a foreign key to a person up here, and a teacher also has a foreign key. So the teacher has a phone and a office that the student does not. So this is how I create my distinction between the student and the teacher, even though they share some things. My attempt at normalizing my database here. All right, I create a person ID. And we'll just do these course ID varchar. This one should probably be a varchar also. I know for the student numbers, you just have numbers, but my person ID is actually TIMO, so I need letters. Over here, course name. I don't actually know if there's a convention for how you write the attribute names, whether it should be, right, I have used what we call camel case. So the first letter is lowercase and then every word, like phone number, is capitalized, but maybe you should have done a Pascal case. I don't know. That's less relevant for this video. So I have my entities. These are the, I think we call them weak entities, or at least it's a ternary relationship, so I'll wait with these. And let's start with a relationship. I just select the association thing here, just the line, and we just move it between here. I want to move it up here, right? And I can click the little star for multiplicity. That's 1, and it causes 0 to 1. Sorry, teacher. So a teacher must be one person, and a person can be a teacher. So this is sort of an optional. Either it's a teacher or a student. I don't know how to indicate that it's a mandatory or it's not optional. The person here doesn't make sense if it's not either a teacher or student, in my case at least. But I will just do like this. All right, so I have that in place. The ternary relationship exists up here. I can just move that up. Association class. Can I remove this name? I cannot. Okay. Teacher course, whatever we call it like that. So up here I will have a person ID, which is a varchar. I will also have a course ID, which is also a varchar. Right. This is the same thing for this one, so I'll just skip that. So now the point is that I can also add some primary keys. I want the person ID to be my primary key, and we put a constraint. Here we go. A new one. I want a primary key, like that. So now it's a primary key. So this one here, the person ID down here, should also be a primary key. PK. Now this one is actually a foreign key to that one, right? So it must reference the person. So I also want to add a constraint called FK. So now it's both a primary key and a foreign key. I could also just say, I could remove that one and say this one is PK FK. Right. So I can put the constraints on. I can mark the primary keys and the foreign keys. Up here I also want a PK. This is actually a PPK and an FK because it's a composite key. So it's a partial primary key. The same thing for this one, PPK FK. So these two together marks the primary key, and the person ID must reference that one as a foreign key, and the course ID references this one as a foreign key. All right, so I have a bunch of extra information that I don't want in my diagram. For example, the accessor here, there's no private or public in databases. I don't have any operations. I don't want these. So let's just hide them. I mark everything. I right click my diagram, and we say operation compartment visibility off. So now all the methods are removed, and I also want to go extended visibility attribute visibility kind off. All right, so this looks more like a database diagram, and I think this one is just a repetition of what we already saw. another relationship here. So that's not really that interesting. There are, I mean, you can probably indicate triggers somehow, for example, or functions in your database. I'm not really sure how you would do that. You would have to come up with your own idea, or maybe that's not actually described in the diagram. I don't know. But I think I'm happy with this version for now. I have marked the primary keys. I can put constraints on. I can give it types if I wanted to. Apparently my name is an int. Should put a varchar here. Doesn't really matter. Right. I have the relationships with my multiplicity. I can use the ternary relationship. So this actually only exists in my EER diagram. It would be changed in the physical diagram to be a separate table. So the teacher course owns course, Trinity, whatever, will become a teacher course owns course. So this is how it's actually implemented. So that just means that you can create another table and put some constraints on it, and that's fine. If you wanted to, you could indicate, well, I cannot do it in this one. If I create if I remove my ternary stuff over here and create it like that, let's just see, because I wanted to show you. We call it owns teacher course. I could not call it that. I have that. I'll call it course teacher, whatever. And I need a person ID varchar. There's a ppk fk, and I need a course ID varchar with a ppk fk. Okay, so I also want to hide stuff, operation, and extend visibility kind, so I don't want that. Because if I just put an arrow here, or an association, whatever, it will just sort of look slightly random. What you could, to indicate it, the foreign key relationship, just make it slightly more clear. Go away. Slightly more clear. We can actually make the lines match. Stop that. Right, so now the idea is that the person here, we follow the line. Okay, it references the person ID over here. And let's just try something similar. And we take this out here. That's not what I wanted. Right, it's just to help the reader a little bit. So now I can see that the course ID here is a foreign key to this one down here. That could improve the readability. Sometimes the person ID is not named the same as the person ID over here, so it's not really clear what it actually references. If I had a teacher-student relationship, the person ID, and it would be person ID and a person ID twice, which doesn't really make sense. So maybe a teacher ID and a student ID. So I guess that would be somewhat clear. But anyway, all right. I think I've talked long enough for this video. I think I've shown you the tools that you need in most cases for your diagram. You can put your keys, your constraints, the relationships, ternary relationships if you need to. It does have an arrow which may not make much sense in this case, but we can just ignore it. Maybe you can even remove it. I don't know. Base. Doesn't matter. You can look for that. All right. I think that's all. So let's stop here. So just remember to use the class diagram and hide the stuff that you don't need. Then it will all be clear to the readers of your project report or the diagram, hopefully, because we used the UML at VIA. Alright, thanks for watching.